Petroleum geology is the study of origin, occurrence, movement, accumulation, and exploration of hydrocarbon fuels. It refers to the specific set of geological disciplines that are applied to the search for hydrocarbons. Sedimentary basin analysis. Petroleum geology is principally concerned with the evaluation of 7 key elements in sedimentary basins: source, reservoir, seal, trap, timing, maturation, migration. In general, all these elements must be assessed via a limited window into the subsurface world, provided by one exploration wells. These wells present only a one-dimensional segment through the Earth, and the skill of inferring three-dimensional characteristics from them is one of the most fundamental in petroleum geology. Recently, the availability of inexpensive, high-quality 3D seismic data and data from various electromagnetic geophysical techniques has greatly aided the accuracy of such interpretation. The following section discusses these elements in brief. For a more in-depth treatise, see the second half of this article below. Evaluation of the source uses the methods of geochemistry to quantify the nature of organic rich rocks which contain the precursors to hydrocarbons, such that the type and quality of expelled hydrocarbon can be assessed. The reservoir is a porous and permeable lithological unit or set of units that holds the hydrocarbon reserves. Analysis of reservoirs at the simplest level requires an assessment of their porosity and their permeability. Some of the key disciplines used in reservoir analysis are the fields of structural analysis, stratigraphy, sedimentology, and reservoir engineering. The seal, or cap rock, is a unit with low permeability that impedes the escape of hydrocarbons from the reservoir rock. Common seals include evaporites, chalks and shales. Analysis of seals involves assessment of their thickness and extent, such that their effectiveness can be quantified. The trap is the stratigraphic or structural feature that ensures the juxtaposition of reservoir and seal such that hydrocarbons remain trapped in the subsurface, rather than escaping and being lost. Analysis of maturation involves assessing the thermal history of the source rock in order to make predictions of the amount and timing of hydrocarbon generation and expulsion. Finally, careful studies of migration reveal information on how hydrocarbons move from source to reservoir and help quantify the source of hydrocarbons in a particular area. Major subdisciplines in petroleum geology. Several major subdisciplines exist in petroleum geology specifically to study the 7 key elements discussed above. Source rock analysis. In terms of source rock analysis, several facts need to be established. Firstly, the question of whether there actually is any source rock in the area must be answered. Delineation and identification of potential source rocks depends on studies of the local stratigraphy, paleogeography and sedimentology to determine the likelihood of organic rich sediments having been deposited in the past. If the likelihood of there being a source rock is thought to be high, the next matter to address is the state of thermal maturity of the source, and the timing of maturation. Maturation of source rocks depends strongly on temperature, such that the majority of oil generation occurs in the 60° to 120° range. Gas generation starts at similar temperatures, but may continue up beyond this range, perhaps as high as 200°C. In order to determine the likelihood of oil-gas generation, therefore, the thermal history of the source rock must be calculated. This is performed with a combination of geochemical analysis of the source rock and basin modeling methods, such as backstripping, to model the thermal gradient in the sedimentary column. Basin analysis. A full-scale basin analysis is usually carried out prior to defining leads and prospects for future drilling. This study tackles the petroleum system and studies source rock, burial history, maturation, migration and focus, and potential regional seals and major reservoir units. All these elements are used to investigate where potential hydrocarbons might migrate towards. Traps and potential leads and prospects are then defined in the area that is likely to have received hydrocarbons. Exploration stage. Although basin analysis is usually part of the first study a company conducts prior to moving into an area for future exploration, It is also sometimes conducted during the exploration phase. Exploration geology comprises all the activities and studies necessary for finding new hydrocarbon occurrents. Usually seismic studies are shot, and old exploration data are used to expand upon the new studies. Sometimes gravity and magnetic studies are conducted, and oil seeps and spills are mapped to find potential areas for hydrocarbon occurrences. As soon as a significant hydrocarbon occurrence is found by an exploration or wildcat well, the appraisal stage starts. Appraisal stage equals, the appraisal stage is used to delineate the extent of the discovery. Hydrocarbon reservoir properties, connectivity, hydrocarbon type and gas oil and oil-water contacts are determined to calculate potential recoverable volumes. This is usually done by drilling more appraisal wells around the initial exploration well. Production tests may also give insight in reservoir pressures and connectivity. Geochemical and petrophysical analysis gives information on the type of the hydrocarbon and the nature of the reservoir. Production stage equals, after a hydrocarbon occurrence has been discovered and appraisal has indicated it is a commercial find, the production stage is initiated. This stage focuses on extracting the hydrocarbons in a controlled way. Production wells are drilled and completed in strategic positions. 3D seismic is usually available by this stage to target wells precisely for optimal recovery. Sometimes enhanced recovery is used to extract more hydrocarbons or to redevelop abandoned fields. Reservoir analysis equals, the existence of a reservoir rock is determined through a combination of regional studies, stratigraphy and sedimentology and seismic interpretation. Once a possible hydrocarbon reservoir is identified, the key physical characteristics of a reservoir that are of interest to a hydrocarbon explorationist are its bulk rock volume, net-to-gross ratio, porosity and permeability. Bulk rock volume, or the gross rock volume of rock above any hydrocarbon water contact, is determined by mapping and correlating sedimentary packages. The net-to-gross ratio, typically estimated from analogs and wireline logs, is used to calculate the proportion of the sedimentary packages that contains reservoir rocks. The bulk rock volume multiplied by the net-to-gross ratio gives the net rock volume of the reservoir. The net rock volume multiplied by porosity gives the total hydrocarbon pore volume, that is the volume within the sedimentary package that fluids can occupy. The summation of these volumes for a given exploration prospect will allow explorers and commercial analysts to determine whether a prospect is financially viable. Traditionally, porosity and permeability were determined through the study of drilling samples, analysis of cores obtained from the wellbore, examination of contiguous parts of the reservoir that outcrop at the surface, and by the technique of formation evaluation using wireline tools passed down the well itself. Modern advances in seismic data acquisition and processing have meant that seismic attributes of subsurface rocks are readily available and can be used to infer physical sedimentary properties of the rocks themselves. See also, bituminous rocks, controlled source electromagnetic, important publications in petroleum geology. References: V. Guerriero. ALll improved statistical multi-scale analysis of fractures in carbonate reservoir analogues. Tectonophysics 504, 14 €24. Bibcode, 2011 TECTP 504. 14 GDOI, 10.1016/J-Tecto. 2011.01.003. V. Guerriero. ALll quantifying uncertainties in multi-scale studies of fractured reservoir analogues, implemented statistical analysis of scanline data from carbonate rocks. Journal of Structural Geology 32, 1271 €1278. Bibcode, 2010 JSG, 32.1271 GDOI, 10.1016/J-JSG. 2009.04.016. Further reading, Brian Frainer. Finding Oil, The Nature of Petroleum Geology, 1859-1920, 232 pages. External links, Petroleum Geology, a forum dedicated to all aspects of petroleum geology from exploration to production, Oil on My Shoes, a website devoted to the science and practical application of petroleum geology. AAPG, a American Association of Petroleum Geologists. Petroleumgeology.org, a website about the history and technology of petroleum geology.